Welcome. This is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium, which took place in Kuala Lumpur, Malaysia. This conference is made possible through the support of the PKI Consortium Post-Quantum Cryptography Working Group and our sponsors SSL.com, Entrust, Keyfactor, HID, and Crypto4A. And with exceptional organizational support from SSL.com, Keyfactor, Logius, POS Digicert, Baker Tilly, MSC Trustgate, and Digitoris. Join the discussion. Join the PKI Consortium. Go to pkic.org/join.
The final introduction before lunch, and interestingly enough, on one stage in Kuala Lumpur stands 3 people from the same city in Canada, and we probably live about 20 minutes from each other. Yeah. So, always funny who you bump into as you travel the world. I have the pleasure here of introducing Samantha Mabey. Samantha has been doing some moderating and hosting, so you probably already had the pleasure of meeting her and hearing her. And Samantha, just to remind you, is the Director of Product Marketing for Data Security Solutions at Entrust. And I also have the pleasure of introducing Matt Rose. Matt is the, I believe now, Senior, is that correct? Thank you. Senior Manager of Sales Engineering for North America at Entrust.
Thank you. All right, thank you everybody for joining our session today. So we are talking about crypto agility, which has been a hot topic the last couple of days. I think just about every single presentation I've heard has addressed it, which is great. We know we need it. Do we know why? Do we know what's driving it? Do we understand it? And are we thinking about it as more than just a technology imperative, but more an organizational-wide level imperative and how it can deliver significant business value? So that's what we're hoping to get into a bit today. So starting off with a definition of crypto agility. So this is a pretty traditional definition that we use all the time. At its simplest, crypto agility is an attribute of a system that allows it to transition from one cryptographic system to another by configuration or policy without impacting the infrastructure around it. So again, a very technical or very traditional definition. It's also pretty narrow. It leaves a lot of how difficult it is to achieve crypto agility out of it. It leaves different dimensions of crypto agility out of it. It also doesn't necessarily address some of the drivers behind it. But this is a very common one, and we've heard a lot about it, and we've seen it. It is a correct definition. But so are these. Crypto agility is also all of these definitions. So these are from some well-respected organizations and experts in the field, and I just wanted to go over some of these definitions with you as well. Dr. Garfield Jones from CISA presented this as his definition of crypto agility at ICMC in San Jose two sessions ago. Designing information systems to encourage support of rapid adaptations of new cryptographic primitives and algorithms without making significant changes to the system's infrastructure. So again, another way of saying the more traditional one that I went through earlier. We've got Dr. Michele Mosca from Evolution Q. What I like about his definition is the second half of it, where he says, because PQC algorithms are relatively new, crypto agility is a key pillar of resilience in the quantum age. Talking about resilience in the quantum age, the need for crypto agility. It's not just about moving from traditional public key cryptography today to PQC, but these PQC algorithms that are standardized, they're not fully baked. So RSA we've been using for 30 years, ECC for 20 years. We are making this initial transition, but we can absolutely expect to make future transitions. So I like that he gives a nod to that. Finally, we've got NIST. So crypto agility describes the capabilities needed to replace and adapt cryptographic algorithms for protocols, applications, software, hardware, and infrastructures without interrupting the flow of running systems to achieve resiliency. Again, a mention of resiliency. And what I like here too is that it talks not just about no impact to the underlying infrastructure, but it also talks about some of the use cases that we need to consider. Little or no impact to the use cases that a business organizations rely on when making some of these transitions. But again, what we're seeing here is a lot of technical definitions. So we want to sort of move beyond that with this presentation. So crypto agility is all of the definitions we just went over. We know that it's more than just configuration and algorithms. Michael Osborne talked about that in his presentation yesterday, which I really appreciated. And then today we're going to explore, again, what's driving that need for crypto agility, the different dimensions of it, expanding far beyond technology, and some of the business value that it delivers. So again, we're facing a growing list of challenges. We're all here at the PQC conference talking about the challenges around PQC. Of course, crypto agility, this is one of the drivers, the need to transition. But I also wanted to bring up some other challenges, the growing list that organizations are facing. And these are the 4 that we're going to go through quickly today before we get into the rest of the presentation. So these are the 4 that I've chosen. The journey to quantum safe. So again, knowing that just about every piece of infrastructure of cryptography is going to need to be updated or transitioned to quantum safe. The sprawl and growth of devices and data. Again, this is creating an explosion of cryptographic assets that are needed to secure them and protect them. Organizational and operational complexity. We're not necessarily doing a good job of all of this today, of managing our cryptography. And the need to move to short life certificates. I'm sure everybody's heard about 47-day certificates by now. So where we're going to start is the quantum threat. So again, advances in quantum computing are accelerating. Right now, we're about $55 billion in investment from some of the largest governments and the biggest tech companies in the world. So of course, with all that research, with all that money, with all the people involved in this, when is that cryptographically relevant quantum computer going to be realized? I was talking to Chris Bailey. He shared some stats on his panel yesterday. But some of the stats that we were going through is a lot of people in his polls said that that could be realized within 7.5 years. So when do they predict that they're going to be ready? 10 years. Those numbers don't necessarily add up. And then we add in the harvest now, decrypt later. Bruno asked everybody if they were familiar. Everybody raised their hands. So we're all good there. We know it's here today. So again, that 10 years to prepare doesn't necessarily add up to this. We also see the NIST timeline, their sunsetting plan. So 2030 to deprecate RSA and ECC, 2035 to disallow it. Again, looking at the timelines, we need to be on this. Data and device sprawl. So again, lots of numbers on this screen. I'll just go over them really quickly. 75 billion connected devices by this year. 175 zettabytes of data. There's a lot of things that need to be secured. And that 75 billion connected devices is connected devices. It doesn't even really address the other part of machine identities, the workloads, virtual machines, containers. We were talking about AI agents as well. There's a lot out there to secure. Everything needs credentials. And those cryptographic assets are, obviously, there's a lot of sprawl there. Attacks on cryptographic systems as well are increasing in number and sophistication. We know this, we see it in the news all the time. Organizational complexity, again, talking about the multiple fragmented tools that are used to manage cryptography enterprise-wide. We hear about outages caused by certificate expiry. Of course, outages to critical business systems being hard to diagnose. Visibility, discovery, inventory, it's impossible for most organizations, whether it's because of the siloed groups or the fragmented tools that are used to manage cryptography. And we know also, linking it back to the PQC transition and the readiness journey, that one of the first steps is assigning accountability, assigning a lead. So organizations, when it comes to deploying and managing PKI, one of the top challenges being no clear ownership. So again, in order to make an organized and orderly transition, you do need that ownership, you need that accountability. And then the last element here, again, we are on a runway for the next few years to go to 47-day certificates. So with the growth of the certificate landscape, for all the reasons that I've mentioned previously, it makes manual processes unsustainable. And I actually love that one of the questions, I think it was a remote question in the CLM panel session yesterday, asked, are people actually still manually, using spreadsheets to manage certificates? Sadly, the answer was not no. So people are still doing that with, again, 47-day certificates, adding complexity to managing those certificates. The sheer volume of certificates out there, you really need to, again, rein in the cryptography, rein in the sprawl, make sure that you know what you have across your infrastructures. Lack of that visibility, again, creating risk of outage and expiry. The need for compliance. The number one cause of breach is credential compromise, again, making it all the more necessary, and of course, just in order to avoid the reputational damage. So with that, we're going to come back to sort of the definition where things started of what is crypto agility, but we're going to do that in a different way. We're going to go into the dimensions of crypto agility, and I'm going to hand it over to Matt to take it from here.
All right, thanks, Sam.
Yeah.
Examining cyber challenges through the lens of people, process, and technology is not new. But applying these dimensions to crypto agility is a useful way to evaluate how these dimensions contribute to the organization's ability to adapt to crypto changes. Crypto agility starts with human capability and awareness. So even the best technology fails without informing or an engaged team. So let's look at some key elements within the people dimension here. So it starts with accountability, right? Someone or some team needs to have responsibility to define your policies, your strategy, and practices around cryptographic assets. Is crypto agility or managing crypto part of your job description? Next, we look at training and awareness. The DevOps or people need to understand cryptographic best practices, threats, and risks. Legal and compliance and business owners need to collaborate and better understand data protection and how it constrains or enables their business. The executives need to understand risk so that they can evaluate and prioritize crypto agility. Process provides the structure needed for crypto agility. It provides systematic and repeatable process. It's the backbone for crypto agility. It informs governance, compliance, and risk around how an organization influences adoption for crypto. So let's look at a couple key elements within this division. So we have policy, management, and governance. So documenting policies, practices, and management of your crypto assets. Risk and compliance. Is your cryptographic standards aligning with the regulatory frameworks like PCI, HIPAA, NIST, for example? Third-party third-party requirements, vendor integrations, disclosing cryptographic mechanics, and supporting algorithm agility. Change management and incident reports, right? Plan for change, but do it safely. Consider cryptographic failure and traceability and audit, being able to have documentation, report and discuss those documentations, and audit and control. Next, we have technology, and this is the foundation that enables crypto agility through design and tooling, right? So there's three pillars that we kind of look at: find, control, and automate. So find, you can't fix a problem that you can't see, right? So your technology needs to be able to provide you that inventory of all those crypto assets. So things like keys, certificates, secrets across your organization. Control. You need to be able to have a centralized management policy that's dynamically in a dynamic way. And these policies are used to distribute to the endpoints of your organization where crypto is used, and then evaluate the compliance and identify risk. Last is automation. You need to be able to automate the life cycle of your crypto assets. I'm going to borrow a concept from the networking days. In networking, you have the control plane, and it's responsible for defining how that data is flowing. So examples of routing policies or monitoring system performance. And then you have the data plane, and the data plane is actually used for the actual movement of that data across your policies that are set at the control plane. So this is a very useful way to think about your technology and capabilities when it's necessary for achieving crypto agility. The control plane here is responsible for defining your crypto and how you use it, enforce it in your organization. And then the data plane is used for crypto operations, executing the crypto operations. Things like providing a key to a database for TDE, or providing a key and certificate to a web server, or even signing a digital documentation for, or applying a digital signature to a legal documentation. So let's start at the bottom here and jump into the technology layer, or the data plane. Here we see capabilities like HSMs, PKI, key management, cert lifecycle management, and secrets management. And here we target a specific persona, right? For example, the operations or IT person that owns that infrastructure, or that DevOps person that needs that or needs to inject that key or secret into the application, right? And agile cryptographic infrastructure needs to provide that standard-based infrastructure or interfaces so that's easy to integrate with, that it has a modern scalable architecture to fit the demands of your systems. And this is a critical components you need in your environment for securing your identities, devices, and your data. So let's jump to the top here and look at what we call the management layer, or the control plane, right? So we're going to have a different target persona here. So we're going to look at the InfoSec person, or the compliance or risk manager, right? The agile cryptographic platform needs to provide that visibility of those cryptographic assets across your organizations, or across your organization. The ability to apply policy and report on compliance, identify any risks, and target any assets that need to further investigation. When crypto agility is done right, it's not just about security. It's about resilience, efficiency, and flexibility. In order for us to better process here, we need to do a better job of describing some of the business values, like reducing risk, avoiding disruption, driving operational efficiencies, delivering compliance, and enabling a scalable innovation are all part of that business value. Reducing risk and driving compliance, crypto agility is the secret sauce to making that journey to quantum safe and orderly orchestrated program, instead of reactive, chaotic fire drill. Generating operational efficiencies and enabling scalable innovation. When guidelines are established, it allows you to move faster. Ease of operation points, centralized cryptographic services allow the product teams, for example, to drive innovative solutions without needing to reinvent the wheel or being a deep expert in crypto. So crypto agility can be a force for reducing cost and driving innovation. I suspect most of us in this room will probably have to ask this question or answer this question. You know, what are we going to do about quantum, right? A comprehensive, capability to manage your cryptographic assets really is the only answer that demonstrates readiness. Crypto agility at the organization-wide level is imperative. It's necessary to respond to driving forces, multiple driving forces, and if it's done well, it can drive significant business value. 4 takeaways that I want to talk about today. Accountability, right? Determine in your organization who is going to be accountable. Inventory. Discover and inventory that crypto assets, keys, certificates, secrets, hardware. Maturity. Figuring out what your maturity is and then building a plan to reach higher. And then implement and execute. Start testing and rolling this into production. As we wrap up our examination of the different dimensions within crypto agility, I wanted to introduce a concept of crypto agility maturity model. It's useful when organizations are going through this journey. It's nice to have a framework to assess where your current capabilities are, right? And a clear step-by-step path forward to improvement. This is the CAMM. It's wasn't designed by me, but a group from Germany, an academic research group that put this together, and it's a very useful framework. It was also referenced in the NIST crypto agility framework white paper. Sorry. I'm beyond the time that I can get into the details of all this, but what I wanted to leave you with is that this is a 5-step model. And the concept here is to deliver different KPIs within your organization to see where your different dimensions are. And then having a score from 1 to 10 or maturity level. Thank you.
Mm-hmm.
Right. Snapping back there, sorry. Do we have any questions in the room or remotely? We have some remotely or in the room? I saw a hand go up here. Giving you the benefit of the doubt, Scott.
No, somebody.
No? Okay.
Question for Matt. In the previous slide, you talked about the CAMM. And level 4 is advanced capabilities. Can you speak a little bit about those capabilities? Thank you.
Being prepared to have practice. Sorry, which one? The level 3 and
Level 4. Level 4.
Level 4. Well, it could be capabilities like your technology, being able to provide those crypto assets, right, in the certificate authority or even in an HSM, right, being able to provide those type of capabilities within the technology.
Okay, so we have a remote question too. This one's actually for Sam. What strategies, this is from Bill, I think he might be the only one online. What strategies manage compromised app-driven IoT at scale, and references 3 million homes? Is an edge-driven approach viable given device resource constraints?
I don't think this is for me.
Say the question again.
What strategies manage compromised, IoT basically at scale? So is an edge-driven approach viable given device resource constraints?
So we're talking about IoT devices and making sure that they're secure.
Yeah. So if you had a large IoT deployment and there was a compromise, what strategies basically?
Yeah. I mean, the way I look at that, I've done a lot of work on the IoT factors at Entrust, and the way I look at it is there's 2 factors, the kind of way I would design an architecture like that. You have a birth certificate that initializes that IoT device, and and that scales to millions, right? So each one has an individual certificate or identity. And then what you do from that point of of you is you use that identity to prove yourself, and then what you get is what we call an operational certificate. And that's the one that you use and maintain to transport that data from that sensor to the cloud, for instance. And hopefully what it is, it's an individual certificate. You don't want to be doing wildcard certs. You want to be doing an individual cert. So if it's compromised, hopefully it's contained just to that one device or one item. And of course, if I'm looking at it from a CA perspective, that issuer and root would be, of course, backed by a hardware security module to protect those master keys. So I'm hoping that in a design like that, I can prevent and isolate where the risk is at.
Yeah, I think it's segmenting to reduce the attack surface is basically the concept or the strategy, so that you can, again, just address one thing as opposed to your whole network of things. So.
And just to double click on that, because we have a minute, I think one of the difficult things with IoT devices is how do you become agile with cryptography, let's say when it's a light bulb in your house. Interested what your thoughts are on those types of strategies.
Yeah, working with the manufacturer at that point, right? It's hard to put technology or security in after the fact. You have to work with the manufacturer to do those birth certificates like I was talking about and establish it there. And now with post-quantum, it's even more important because these IoT devices have shelf lives of 15, 20 plus years. And so now you have to start looking at and designing that approach into your IoT. And then how do I manage that IoT? Because it's just like anything. If I'm still having a post-quantum certificate, I still need to be able to manage. I still need to be able to renew that certificate. So building on all those processes and stuff is important.
Wonderful. And we have another minute or two. Any other questions in the room? No? Anything else online, Scott, that we can... No, we're good? Great.
Thank you.
Please welcome or join me in saying thank you to Matt.
Thank you very much.
And to Samantha. Thank you very much both.